Hello, my dear friends. Welcome back again on your favorite channel, that is on JE Physics Maniac. And in today's lecture, I am going to elaborate a very interesting thing. It's a common problem known to all serious candidates across the periphery who are seriously preparing for JE Advanced. Now, it's a question from the famous book, the one and only Irodov. The question number is also given here, that is 1.16. But here in this particular discussion, I will try to enlighten you from different aspect, that I am going to discuss this question from 4 different methods. So yeah, it's one question, 4 different methods, and we will touch upon all the possible part of basic mathematics. We will touch upon vector algebra, we will touch upon the basic coordinate geometry, differentiation and everything. Okay, so without wasting much time, let us proceed. The question is known to all of you, but still I will narrate it, that there are two particles, particle 1 and 2. They have started moving from these two positions with velocity v1 and v2, and they are at distance L1 and L2 away from this common point of intersection. And they are asking you what is the distance of closest approach, or what is the distance when it will become minimum, and they are asking the value of it. So without wasting much time, let's proceed. So here in this case, in method 1, as you can see in the diagram, that here is particle A and here is particle B. This is the common point of intersection. So we are going to visualize the motion of B with respect to A. So what I am supposed to get, that velocity of if I want to calculate velocity, just one second please, velocity of B with respect to A is simply is equal to VB minus of V, correct? Or vice versa, you can take velocity of A with respect to B is equal to VA vector minus VV vector. So basically it will appear that as if they are moving in this along this line, and it's a very common concept that on this line, if I drop a perpendicular from the point B, this will be the minimum distance between the two line of approach. So BM is equal to, we can write BC cos theta, right? And now I am going back to this triangle, that is triangle AOC. Here in this triangle, if you check first from the vector method, tan theta is equal to V2 by V1. It's quite easy. This is V1, and there in this direction V2 is there, direction wise minus V2. So tan theta equal to V2 by V1. And again from this triangle AOC, I can write that CO by AO, this vector, this one divided by AO, this vector is basically tan theta. Now this is L1, and this distance basically I am taking, if this function is y, so I will take L minus y. I have written in terms of V2t, but you can write, if I take this V2t function as y, so I will take this as, I will take this portion as simply L2 minus of y. All right, fine. Now, so in this calculation, I think I have taken this value as y only. So there is nothing much to change over here. So I'm just taking this value as y1 here. So I'm taking this itself as y value. So this is simple. Y by L1 will become tan theta. So one tan theta is V2 by V1, another tan theta is y by L1, correct? Right. So if I equate them, I will get y in terms of known values, that I am getting L1 V2 by V1. So y is coming to be L1 V2 by V1. Now I am going to calculate the value of BC. So what will be BC? Now from here, if you check in the diagram, then BC is coming to be this much only. So this is BC. So BC will become what? Simply L2 minus y, right? And the y value is already done. So I am directly writing with the help of equation that BM is equal to, this is BC into cos theta. All right. Now y value I already got. So if I substitute the value of y here in this equation, so I will get L2 minus L1 V2 by V1 into, now tan theta is equal to, we got V2 by V1 here, as you can check, right? So if it is tan theta, then cos theta will become what? V1 by root under of V1 square plus V2 square. Substituting the values, we will get BM is equal to L2 V1 minus L1 V2 by root under of V1 square plus V2 square. So we got the minimum distance. So this is basically L minimum between them. So one method is over. Let us go for the next method. So here in this case, I will use an idea from relative motion. What is that? That I am assuming that after some time t, A is here at the position A prime, and B has crossed this, and B is somewhere here at the position B prime, right? Now A is moving in the direction with velocity v1 and B is moving in the direction with velocity v2. What I am assuming that when the distance between them is minimum, along the line joining, that is along A prime B prime, their relative velocity will become 0. Why? You try to understand. Suppose there are two particles 1 and 2, and this is the line joining between them. One has velocity in the direction v1 and 2 has velocity at the direction v2. So if there is any anomaly between the magnitude of v1 and v2, if v1 is greater than v2, then the separation between them will decrease, right? Because this is moving faster. If it is opposite, that is v2 greater than v1, so two particles will move faster away from particle 1, so the distance between them will increase. So whether v1 greater than v2 or v2 greater than v1, separation between them will increase or decrease. But if it is minimum, then it should be what? v1 is equal to v2, right? So that means along the line joining the two particles, when relative velocity is equal to 0, it is the minimum separation between them. Alright, correct. So I'm using that. So in that direction, v1 has component v1 cos theta. This angle phi is getting 90 minus theta as per the geometry that we are calculating over here. So v2 is in that direction. So v2 will have a component of v1 cos phi in this direction. Fine. So cos phi means 90 minus theta, so it will become v2 sin theta. So if I equate them, v1 cos theta is equal to v2 sin theta. You come back to this question. You see here, right? Now tan theta is here, in this case we are getting v1 by v2. Now again, you go to this triangle. In the diagram, if you go to the triangle A prime O B prime, triangle A prime O B prime, from there you can calculate tan theta is equal to B prime O divided by A prime O, right? If I substitute the values, B prime O, this much value only, this total is equal to v2 into t, this much is L2. So this much will be, from here to here, it will be v2t minus L2. Clear? This is clear to everyone? Fine. So here tan theta is equal to, I am getting v2t minus L2 divided by L1 minus v1t. How? This total distance is L1, out of which this much is v1 into t. So this much distance will be L1 minus v1 into t. Simple geometry, correct? So now from equation 1 and 2, we will get v1 by v2 is equal to v2t minus L2 by L1 minus v1t. I will get time. So this time is basically the time required for the minimum separation between the two particles. So again, separation between them is this separation, that is A prime and B prime. So if I use the Pythagorean triplet, I will simply get that A prime B prime equal to root under of L1 minus v1t whole square plus v2t minus L2 whole square. So from there I will get L minimum. So this is again the value of L minimum. So two methods are over. Let us go for the third method, and here we are using differentiation. Bluntly, with the help of method 2, I am calculating the separation between the particles at any random point of time. I can express by this equation, right? I am simply using the Pythagorean triplet over here. So by using the Pythagorean triplet, I got the separation. Now we know separation has to be minimum when time derivative of that particular separation is equal to 0, right? So after calculation, I again got the value of t minimum, which exactly I got earlier also. You can check. This is the value of t minimum. So here also t minimum is coming. And once I got the value of t minimum, if I substitute in the equation of Pythagorean triplet, I will get the minimum separation between them, right? So method 2 is over. Now let us go for the method 4. This method 4, I have used simple coordinate geometry and I have taken the help of method 1. So from the diagram, point A coordinate is minus L1, 0, point B coordinate is 0, minus L2, right? Now here tan theta is equal to v2 by v1 that we have calculated earlier. So what I am doing here, I am calculating the y-interception of the line. So what is y-interception? It is simply coming to be L1 v2 by v1. Now if I go back to this equation, that is y is equal to mx plus c, it is having a negative slope and negative y-interception. After substitution, I get an equation like this. Alright. So after getting this equation, it is like getting mx plus ny plus c is equal to 0. From there is a point from which I am calculating the perpendicular distance. So simply applying the formula, I get the value of L minimum, right? So this is a very interesting thing. In whatever way you want to project a question, you can project, and by doing a same question in different way will open up your mind to have a diversified thinking. Like, so whenever you are going to solve a question, whenever you are going to see a case study, try to get that case from different angles, because that is exactly what we need, the hard training of mind in an unidirectional and proper way, right? So I hope you have enjoyed, and if you enjoy Definitely, your one like, share, and subscribe will encourage me to do more, and hope I will come up with many such interesting case studies and questions in future. Thank you very much. Thank you.